All right. Hello, chat. Hello, AP Calculus. Move this down a smidge. What's going on, chat? What's going on, Jason? What's going on, Ellie? How you doing? You guys having a nice lazy Sunday filled with calculus, I hope. We got 6 viewers at the moment. Let's go. Get that microphone volume up. Hope you guys are having a nice Sunday. Love Sunday. Hello, N, which I'm assuming, I don't know. I thought it was Robert or Andrew Lee, but I could be wrong. Reveal your identity if you choose. Solid Sunday from Andy. All right. Icola. Now I see it's like Nicholas. I gotcha. I see. Very cool. And then Dragon Fruit is Robert. Okay, yeah, I recognize that from your Discord alias, so that's cool. I hope you guys are enjoying yourselves. We've got one FRQ to complete today. Okay, if you were not aware, this FRQ is posted. I'm going to go ahead and do this. This FRQ is posted right here. This is a YouTube live FRQ. This is the one I'm going to do. And the reason why I picked this one is because it kind of walks you through the difference between the mean value theorem and the intermediate value theorem. And I just think that's really important because a lot of people are struggling with that. Hello, Lizzie. This is Emma P., not my great grandma Godrun. Okay, well, hello, Ellie, or hello, Emma and Emma's grandma. Or her YouTube account, I guess. Hi. Anyways, this is the FRQ I'm going to do today, guys. My plan is to do this FRQ. It'll probably take about 15 minutes and then open it up for Q&A, just kind of like we're vibing in class. If you have any questions or if you specifically want me to solve a problem, that's what we'll spend the last chunk of this FRQ doing. So for the 9 viewers, thank you for tuning in. I hope you guys are, beginning your studies. I'm really excited. The AP exam is coming up. And we've got 1 week left, 1 week to prep and study. I'm going to go ahead and pull up the FRQ on my iPad with my technology that allows me to go 10 minutes at a time. 10 minutes. Okay, Aircast, that's me. Boom. Boom. Started reading the Percy Jackson series, The Lightning Thief, as my daughter requested book 1. And I do not want to pay for this. No, go away. And I started reading book 1 along with her. It seems like it's very good. I'm enjoying it so far. Okay, chat, it is time. It is time to begin solving this FRQ. This FRQ is from the 2019 practice exam. Recall, going back to my doc just for a second as I waste part of my 10-minute time. I actually don't even know how to minimize it. Oh, no, that's right. I have to go like this, maybe. Anyway, okay, good. Thank you. Yes. No. Okay, that's fine. That'll do. This right here, these multiple choice questions were from the 2019 practice exam. I just wanted you guys to be aware that the FRQs are here also. You just have to scroll down past the multiple choices. Okay, I cut them off, it seems. All right, well, it looks as though I'm glad I double-checked that. I did not give you access to the 2019 FRQs. I will give you access to those FRQs. And that's actually where I got the quiz that I gave you in class, as well as this. Alex, you've missed nothing. Welcome. Good afternoon. We are just jumping into the FRQ that I had posted. I'd like to complete. It's this one right here. We're just starting right now. All right, so let's read the FRQ. It says, Brandon and Chloe ride their bikes for 4 hours along a straight, flat road. Brandon's velocity in miles per hour at time t is given by a differentiable function b between 0 and 4. Values of b of t for selected times t are given in the table above. Okay, so this table right here looks as though it's Brandon's velocity. Also, it's given as a differentiable function. Alex, my day's been solid. It's a real solid Sunday. Kind of, lazy Sunday. Love to see it. Chores, laundry, And then it says Chloe's velocity in miles per hour is given by this function down here, and it is a piecewise function c. And then it asks us the question, how many miles did Chloe travel from 0 to 2? Okay, so that's what I'm going to start solving right now. And as we know, if I have a velocity function and I'm asked for how many miles, I must integrate, right? Because velocity is given in miles per hour, and then I want miles. I integrate to go backwards. So my job here is to integrate oh my gosh, wrong pen, to integrate from 0 to 2. Integrate from 0 to 2. Now, this is a piecewise, and it's actually defined in two separate pieces. The piece that I want is the piece from 0 to 2. So I'm not going to use the quadratic. I'm going to use the exponential function. All right? So I need to integrate TE4 minus t squared dt. This is a no calculator problem, chat. No calculator means I have to use a u substitution because I do not know how to integrate the product of two functions. Right? This is t times e, and I don't know how to do that, so I use a u sub. We're going to change my color to pink. We're going to let u equal 4 minus t squared. We're going to then say du is negative 2t dt. And if I isolate, I get negative 1 over 2t du is equal to dt. The whole reason why I wanted to do this is because this dt is now going to go this dt. So I'm going to take the negative 1 over 2t du, and I'm going to plug it into my original integral in place of that dt. Okay? So I'm going to go ahead and simplify now. This is going to equal, I'm going to take the negative 1/2 right out of the integral. All right? It's now going to be the integral. I will change my bounds. I might as well just do it right now, honestly. This expression right here relates u and t. And I need to change my bounds because these bounds right here in my original integral are bounds for t, and I need my bounds to be u. So I essentially just use the formula, u equals 4 minus t squared, and u equals 4 minus 2 squared will be my new upper bound, which is 0. This is my upper. And then u equals 4 minus 0 squared will be my new lower bound. Lower bound. My dishwasher is done. If you can hear that beeping, chat, don't be alarmed. It is my dishwasher. So I have a new integral from bounds 4 to 0. And just remember, you have two choices. You don't have to necessarily do that. If you wanted, you could have left the bounds as 0 to 2, integrated the function, and then put the 4 minus t squared back in place of the u. It's up to you. I like to change the bounds so I don't have to worry about it later. Okay, so what's left inside this integral now? Well, I'm literally I have my bounds. This is now the t, and the t on the denominator right here will cancel out. So I'm literally just left with e to the u, du. Right? That's the nice thing about that t being canceled with the t in the denominator. And one more reminder, chat, I moved the negative 1/2 out of the integral. Before I actually integrate, the last thing I'm going to do is switch my bounds, because you can't integrate from a number to a smaller number. You have to flip them. And what that does is it causes a negative to be removed. So this is now 1/2 times the integral, or of the integral 0 to 4 of e to the u du. Now I'm going to integrate. When are you supposed to use u sub, asks Nicholas. Nicholas, you're supposed to use u sub when what you're trying to integrate cannot be integrated. So things like if two functions are being multiplied to each other, if two functions are being divided, if you have one function that's very complex because it has multiple layers. All of those are reasons when you should integrate. Okay? So we using u sub. We integrate using u sub. So now we're done. We're actually just going to take the antiderivative. So this thing right here is just going to be 1/2 e to the u evaluated from 0 to 4, because of course the antiderivative of e to the u is e to the u. I'm going to plug in my upper bound and my lower bound. So this is going to equal, this might not be the most organized, but I suppose I can just keep going underneath here. I'm looking at my screen. It looks okay. Is this the format of the exam we will be in with room to work below? Katie, I do not believe this is the format of the exam. This is the format of a practice exam taken from like a booklet where you would write your answers in. That's why there's room. I believe yours is all squished together and you're asked to do your writing in a separate booklet. Okay, so you'll have to just kind of transfer all your writing, which isn't the end of the world, because then you can have like, your writing next to, like, side by side the question. That sometimes is helpful. Okay, so we're going to integrate. We're going to plug, or we already integrated. We're going to plug in the upper bound. The upper bound is 4. The lower bound is 0. And this is just equal to 1/2 e to the 4 minus 1. If I simplify e to the 0 to 1, and the unit on this is actually just miles, I believe. Miles. So to answer the question, Chloe traveled 1/2 times e to the 4th minus 1 miles. Do you have to factor or multiply that 1/2? I don't believe so. I think you can leave it in factored form. A is complete. Let's look at B. B, at time t equals 3, is Chloe's speed increasing or decreasing? When speed is in question, you must find the velocity and the acceleration. You must determine if they are the same sign or alternate signs. Why did you drop the integral and use a, I can't see the last thing, use a I think Nicholas is asking. Looking back at my integral, Nicholas, why did I drop the, oh, I see. Nicholas, this right here, is this what you're looking for? You're talking about this? This is a bar. It's not the letter I. It's a bar basically stating that I have finished integrating and I'm now going to plug my bounds in. So I have not integrated yet, have not integrated. I did integrate. That's when the bar shifts over to the other side. If that's what your question was, I hope that helps. Okay, so in order to solve this problem, I need to find the velocity of Chloe and the acceleration of Chloe at exactly t equals 3. Let's start with the velocity. Now the velocity is given by Chloe's table. So I just have to find the actual value of Chloe's table. So I'm going to go back up to my table. And I'm actually defined here this time, okay? Because 3 is in there. Easy clap, Mr. Schachter. That's right, easy clap indeed. So 3 is in here, so I'm going to use 12 minus 3t minus t squared. I'm going to plug the number 3 in there. Okay, so I'm going to plug the number 3 in there. So that's 12 minus 3 times 3 minus 3 squared, which is -6. So I found out that the velocity is negative. So now what I want to figure out is what's the acceleration. Well, the acceleration, which is the derivative of velocity, is just the derivative of the piecewise function. That's not too difficult. I'm just taking the derivative of this, okay? So the derivative of this is -3 minus 2t. So I need to plug the number 3 into -3 minus 2t, where t is 3, and that's -9. And that's the acceleration. So therefore, the answer to the question is at t equals 3, Chloe is speeding up. At t equals 3, Chloe is speeding up. By the way, this is the same thing as speed is increasing. If this makes you nervous and you want to state exactly what the question said, then you can just rewrite that. Yes, I'm aware that you only let me do 10 minutes at a time, software. Okay. I'm going to try to connect again, but if I remember from our last review together, I had to close out of the program entirely for the second connection to work. We're going to take a peek-see. I'm trying to reconnect at the moment. We're hoping it just goes right through because that would be convenient. It does not appear it's going. So we're going to close the program out. Goodbye, program. I'm going to open the program up again. I'm going to try again. 10 minutes at a time. Use this for a water break. Goodbye, program, says Jason. Yes, indeed. Goodbye, program. Rip, we miss you. Oh, there it is. Okay. We're ready. Sweet. We're back. We max screen. Boom, there it is. The answer is Chloe is speeding up, or her speed is increasing since velocity and acceleration are both negative at t equals 3. Done. Boom, there it is. Hello, program, says Ellie, and yay, says Jason. That's right. We're back with 0 interruption at all. Cool, cool. All right, there you go. B, complete. Letters C and D now start us on that path of mean value, intermediate value. What's the difference between the two? When do you know which to use? Okay, so let's read this question. It states, is there a time between 0 and 4 at which Brandon's acceleration is equal to 2.5? Now, justify my answer, of course. Whenever there's whenever there's a question that begins as, is there a time? I want you guys immediately to think of intermediate value theorem, mean value theorem, and we did one FRQ where is there a time that it was extreme value theorem. That one was, is there a time such that f of c is greater than or equal to all other f of x values on the interval? And if we proved it was continuous, the answer was yes, because extreme value theorem states that every function that's continuous has a max and a min. Okay, but usually it's not the extreme value theorem when it says something like this. It's usually mean value theorem or intermediate value theorem. So how do you tell the difference? Well, let me explain. Okay, the difference between the intermediate value theorem and the mean value theorem is that the intermediate value theorem is only focusing on one function. So I'm asking you, does this one function hit a certain value in the interval? And typically to do that, you find out that it's above that value and below that value. And therefore, if it's continuous, it must eventually be that value. Mean value theorem is focused on a function and its derivative. And it basically states if you find the average rate of change, which is the slope of the secant, and it comes out to some number, that at some point the slope has to actually equal that point as well. It's kind of like, you're driving in a car. And if I said, your average speed over your entire journey was 60 miles an hour, do you have to have gone exactly 60? Yes, at some point you had to, because if you constantly go under 60, your average cannot be 60. And vice versa, if you're constantly going 80, your average is not 60. So that's kind of the difference. This particular question, because it's referring to Brandon's acceleration, I'm thinking it's going to be mean value theorem. Because let's say it wasn't. Let's say it was intermediate value. What I would need to do is working just with the acceleration function, which is the derivative of velocity. I would have to prove that it's above 2.5, below 2.5, and therefore, if it's continuous, it must be 2.5. But the problem with doing that is if I look back at this function, I have Brandon's velocity. I don't have Brandon's acceleration. And sure, I could pick time intervals between these things, that it's, I could potentially find out the rate of change between those time intervals, but I don't think that's what the question's asking. Because I'm dealing with a table, I think the question wants me to do mean value theorem. I think the question wants me to do f of b minus f of a over b minus a and prove that that's equal to 2.5. All right? And if you're not sure, you can always start. And if it doesn't equal 2.5, perhaps they wanted you to use the intermediate value theorem. But I'm fairly certain this one's mean value. Okay? Checking my chat. Got it to work. Okay. Where do you access the FRQ predictions you introduced to class on Friday? Okay. I can show you that in 2 seconds. I'm going to come back to that question. Okay. I'm going to write a little note there to come back to that so that I remember to answer that question. I just want to use my 10 minutes while I have this thing open. Okay, guys, we're going to go ahead and try this. In order to do the mean value theorem, what I need to do is find the average rate of change from 0 to 4. What that means is I need to find Brandon's value of 4 in the table minus Brandon's value of 0 and divide it by 4 minus 0. For this to have worked, I'm hoping that this is equal to 2.5. Okay, so B of 4 is, I'm going to delete this giant circle. B of 4 is 11. B of 0 is 1. So this is going to equal 11 minus 1 over 4 minus 0, which is 2.5. Yes, right? You think to yourself when you're taking this exam, yes, I got 2.5. That's exactly what I needed to for this mean value theorem to work. Let's go ahead and state, how do I say this? What's the most important thing? The most important thing is that you say this function is continuous. The mean value theorem and the intermediate value theorem, they mean nothing if the function is not continuous. Because you can have a function below, it could just jump right up to be above. It doesn't necessarily have to cross, right? So the first thing we're going to do is we're going to say, since b of t is differentiable, it is continuous on 0 to 4. This is very important, okay? On your AP rubric, this will be one of the points. Verifying continuity. Okay, so since it's continuous, then by the mean value theorem, there is a time t between 0 and 4 such that b prime of t is 2.5 miles per hour squared. Okay, and that's because of this. because the mean value theorem, which you do not need to define, do not write me a textbook. Do not say the mean value theorem guarantees when the average rate of change is equal to the instantaneous rate of change, and therefore b of 4 minus b of 0 over 4 minus 0 is equal to b prime of 2.5, or b prime of x equals 2.5. You don't need to say that. Your AP grader understands what the mean value theorem is. You just needed to do this, and you needed to do this. Those are the two most important things. And also, of course, without a shadow of a doubt, you need to credit your theorem as well. You need to say the phrase mean value theorem. Okay? Check in the chat. Do you have to state that b of t is continuous because it's differentiable? Yes. Yes, Emma, because the function never said it was continuous. You needed to say because it's differentiable, it is continuous. Otherwise, your AP grader may have just thought that you were just saying it's continuous because you really hoped that it was continuous to do this. What if I wrote average value theorem? Katie, I'm not entirely sure. Does our text refer to the mean value theorem as the average value theorem? I'd have to look that one up, Katie. I'm not sure if those are interchangeable. Mean value theorem is definitely what I would say. Couldn't you get a value for the mean value theorem that's not 2.5, but there could be an acceleration of 2.5? Yeah, but Emma, in that case, you wouldn't be doing this problem this way. If that was the case, I'd probably be doing intermediate value instead, which is what we're going to do in the next question. Can you abbreviate MVT, or do you have to write mean value theorem, Songbird? Yeah, you definitely can abbreviate MVT. In fact, on the College Board rubrics, they often will abbreviate MVT as MVT. They don't write it all out. Okay. All right, we're on D, letter D, and I'm probably going to run out of my 10 minutes in a second here, but we're going to do as much as we can. Is there a time t between 0 and 2 at which Brandon's velocity is equal to Chloe's velocity? Well, I'm actually, kind of thinking about this question as we're trying to figure out if this is true, right? I'm trying to figure out if this is true. And this isn't necessarily what I would write for my AP exam. This is just me as your teacher helping you think about this problem. Trying to figure out, is B of t ever equal to C of t? Oftentimes, when I solve a problem this way, I move over one of them, and I set this thing equal to 0. Because, oops, I forgot the C. Because as we've kind of talked about together, it's much easier to find a 0 of something than it is finding out when they're equal, right? Because they could be equal at 2,500 or 5.7. It might be harder to figure that out. But it's easier to find a 0 because then you can just look at the axis and figure it out. So the first thing I want to do is figure out, okay, if this thing is ever equal to 0, now I've got values of velocity of B, Brandon, and I've got values of velocity of C. And that's why in this particular context, I'm thinking intermediate value theorem. Because if I'm trying to prove that B of t minus C of t is 0, all I really need to prove that, number one, it's continuous, and number two, it goes above 0 at times and below 0 at times, and therefore it has to be exactly 0. So the first thing I'm going to do is try to figure out where my interval is. Okay, my interval is 0 to 2. So what if I plugged the lower endpoint into both of these functions? What would that equal? Well, if I look at the chart, B of 0 and t of 0, I've got the initial condition of 1, which is that. And then if I look at C, which is down here, and I use a 0, I'm looking at this function. If I plug a 0 in there, I get 0, and there goes my iPad. Okay, we're going to learn from my mistakes, and we're not going to try to reconnect. That reconnect button is a scam. I just want to close it. I'm going to click reconnect only to get this interface to close. Then we're going to open again. Anyway, I got some questions. I'll read that in a second. So if you don't get 2.5 through the MVT, you should do IVT. Yeah, I definitely think that's an accurate statement. Emma and Emma's grandma, I think that is accurate. If you don't get the value 2.5, then you're not going to use mean value. Perhaps try intermediate value. Okay, boom. My 10 minutes begins. Maybe? Hopefully? Yeah, 10 minutes. Okay. Thank you, app. We're back. All right. So anyways, we found this to be 1. And then I got to find B of 2. Oh, that's right. It always defaults me to that thing. B of 2 minus C of 2. Now, what I'm doing is I'm using the endpoints. I'm using the lower endpoint and the upper endpoint to find the values. So B of 2, according to my table, is 1.5. And then C of 2, according to this, is I need to use this piece right here. I have a lot of notes. I'm going to erase them so that I can look at this. And if I plug in a 2 to that piece right there, it's just going to be 2. So b of 2 minus c of 2 is 1.5 minus 2, which is negative 0.5. All right? This is excellent evidence that the function can somewhere, at some point in this interval, it has to be 0. Because if it's continuous, meaning it doesn't have any jumps or anything weird, and at 0 it's 1, and at 2 it's down at negative 0.5, it has to cross the x-axis at some point. Let me write my final answer. First of all, very important, since b of t and c of t are both continuous, the function that I've been working with in this problem, b of t minus c of t, is continuous. You do not need to write me a textbook on that. If you have two continuous functions and you subtract them, it remains continuous. You don't have to say that, okay? So the function's continuous. Then we're going to say, since b of t minus c of t is, oh, I suppose I should plug in 0. Let's plug 0 in. Since b of 0 minus c of 0 is greater than 0, and b of 2 minus c of 2 is less than 0, by the IVT, there is a time on 0 to 2, I'm going to kind of go down here, that b of t minus c of t is equal to 0, which proves b of t equals c of t at some point in that interval on 0 to 2. Okay, so once again, they're kind of, oh, Mr. Schachter, get out of here. Mr. Schachter, get out of here. I was in the way of the text. So once again, we're going to say, since b of t and c of t are both continuous, b of t minus c of t is continuous. And since it's positive at 0 and negative at 0, since it's greater than 0 at 0 and less than 0 at 2, by the IVT, there is a time on 0 to 2 that b of t minus c of t equals 0, which proves b of t equals c of t at some point on the interval. Okay, so that's just kind of what I'm looking at. I'm going back, I'm reading. Will this be saved and uploaded? Yes, it will be saved and uploaded immediately after the conclusion. How do you know which part of the piece to use for c of 2? I'm just using the function value, Genevieve. It's only defined at the top piece for 2. So I only use that. Did it tell us that c is continuous? I believe it's somewhere told us, although I don't necessarily know if I need to worry that c is continuous, because c is a piecewise function that's joined together of two continuous functions. And this is where I think it gets a little trivial. You don't need to explain that a exponential is continuous and a quadratic is continuous. I think it's trivial to explain that c of t is continuous. It's continuous. Okay. I think you look at the inequalities. Oh, I see just Andy answering the question. Thank you, Andy. Is this sufficient? Yes, there is a time when Brandon's velocity equals Chloe's velocity, since b of 0 is greater than c of 0. But at b of 1 is less than c of 1, they're continuous, so the graphs of their velocities must cross at some point. Yeah, Emma, I think that's fine. As long as you're saying according to the IVT, I think you're definitely talking about what we need to be talking about, what we need to say here. Okay, I've reached the end of the questions in the chat. Guys, I'm going to put this up for one last second. Any more questions before we dismiss this FRQ? Take a water break while you guys think about that. Okay. Emma asked, where do you access the predictions? The predictions are accessible on our normal class doc that we've been using a lot of. They're at the tippity top, right here, Shack Picks. And you know what? Just to make life easier, I think I'll also add them to the bottom of the doc. They are right here. Here are your Shack Picks. the FRQ topics that I am fairly certain about for your exam in 2024. And if we're watching this in future years, what year is it? I hope you're doing well, Mr. Schachter and class. I wonder how these predictions compare to the year that we're currently prepping for. Okay, folks, we've hit the Q&A period of the live review. What I'd like to offer you up an opportunity to do is to ask me anything. You want to ask me a general question? Would you like to ask me to find a practice problem? I'm here for a half an hour. If you feel as though that was sufficient, you'd like to leave, take care. We got 14 viewers. Happy Sunday, everyone. Happy Sunday. Cool. You guys are thinking I'm going to open up my Google Drive. I'm just going to kind of get ready. Going to go into AP Calc. I'm kind of get my clicking ready in case I got something. Sunday Fun Day, you know it. Sunday Fun Day. Got access to all sorts of materials right here, guys. We could do anything. You know what I could do too while you guys are thinking? I could grab this doc right here, okay? And I could open up the AP Calc review, and I could just start looking down. Can we take a look at a related rate problem? Looking at Andrew Lee asks, can we take a look at a related rate problem? Absolutely can take a look at a related rate problem, Andrew. And then I've got Genevieve. Could you do one of those problems with the arc sine triangle thing? Yes. Yes, Genevieve, happy to do that. Let's try a related rate, then let's do an arc sine. All right, let me go get a related rate. So we are in 4-6. Okay, I'm going to just grab the answer keys so I can find a good one. Now, related rate, that's Andrew. What are you looking for? So there's a lot of different types. So there's one that's like a shape. We've got the cone. Cones are sometimes difficult because we needed to use a proportion. This one is kind of tricky. This one you had to use similar triangles in order to figure out this related rate. You got the sides of an equilateral triangle. This is nice. This is pretty good. A few questions about a sphere. There's a lot of pieces here. I don't know if you have a preference, Andrew, but we got trig one here. These are good related rate problems. Number 5 looks pretty good. Cool. Let's do number 5. So we are just essentially doing this problem right here. I'm gonna I'm assuming my thingy has ended. It has. I'm gonna get a fresh. Oh no, it's at a minute. Can I just close it so you're not gonna interrupt me? Close. No, doesn't want me to. Oh, what if I actually kill this? Here you go. Boom. There's nothing to cast. Aha! You have nothing to cast anymore. How can you continue to run? Right. Right. Okay. Could you do a triangle? Yep. I skipped over one of the questions. When determining whether or not something is continuous for the IVT, MVT extrema, do you have to consider all of t or x or just the portion? Just the portion, interestingly enough, Emma, that's a great question. Just the portion in which you're trying to use the function, does it have to be continuous? Although, I'm not going to lie, it's usually always either continuous or not. But, yeah. Okay, open up a fresh doc. Fresh doc, new doc. Let's go ahead and solve this problem. Now, I'm going to do something a little strange, but what I'm going to do is move this out of the way so I have access to the question. And I am going to actually do something really, really crazy. I'm going to take a photo if I can. I believe I can. Take photo? No, take photo. Take photo of computer screen. It's a little strange. I don't know. Oh, it's asking me what I want. I want the whole photo. Why would I just take a photo only to crop the photo out? Keep scan. Okay. Thank you. Now you're all set. Going back to this. All right. Ready for next. Okay. Save. Save. You guys got a good view of my keyboard just sitting there. Nice. All right. Thank you very much for doing that, computer. I now have access to the text for you guys as well, so we can take a look. Okay, we're going to go ahead and solve this problem. This is a related rate for Andrew. The text says, The radius of a sphere is increasing at a constant rate of 0.04 centimeters per second. Note the volume of the sphere with radius r is equal to volume equals 4/3 pi r cubed. At the time when the radius of the sphere is 10 centimeters, what is the rate of increase of its volume? So essentially, I always tell you guys to start these related rates out by doing a what do we know and what do we need? All right, so in this case, we want dv dt. And we know that it says the radius of the sphere is 10 centimeters. And in the directions, it says the sphere is increasing at a constant rate of 0.04 centimeters per second. That's dr dt. We know dr dt is equal to 0.04 centimeters per second. Now, interestingly enough, the reason why we call this unit related rates is because you're always going to have two or more rates that are related by a single equation. The question then asks, what is the rate of increase of its volume when the radius is 10? The radius is 10. This is our frozen information. Recall, you can't use the frozen information until the end of the problem. Okay, so now all we have to do is write down the formula, which is, according to my screen, volume equals 4/3 pi r cubed. Okay, and now we need to take the derivative. Now there's only one variable here on the left and one variable on the right, no product rule or anything crazy needed. So first we're going to do the derivative of volume is dv dt. And on the right side of the formula, we're going to take the derivative. Now the 3 from the r is going to come down and cancel with the 3 on the denominator. So it's going to read 4 pi r squared times dr dt. And that's because, of course, you have the dr dt needed to be chained in a related rate because time is always the variable in your related rate problem. So everything is chained with respect to time. dv dt is what we need, so we do not know it. And then you've got 4 pi. Just a heads up, chat. My wife just got home from the store. My dog is going to go absolutely insane in about 5 seconds. Don't be alarmed when my dog goes insane. Okay. R is 10, that was frozen information, and then dr dt is up here at 0.04. And then if you solve this all out, according to the answer key, you get 50.265 centimeters cubed per second. Okay? 50.265 centimeters cubed per second. So Andrew, that's just a typical related rate problem. I hope that you find it easy. I lied, my dog's not going insane. Oh, because my wife went, there she goes. My wife was through the back door trying to be considerate of the live review, but the dog figured it out anyway. Okay, so Andrew, if you want to take a look at more of those examples, they are under section 4.6 related rates. Oh, thank you so much, chat. My wife just brought me a pink drink. Let's go. It's a good day. It's a good day. Right. That's excellent news. Okay. You're welcome, Andrew. You're welcome. There's plenty more examples there. I'd like to now shift to go get a problem for Genevieve, which was those arc trig problems. I'm going to find one. I believe it was in unit 3. Unit 3. And it was like not 8. I'm checking. Oh, 8 is shack chart. 8 is shack chart. What do I need? No, I don't need that. I need 7 then. Or is it 9 perhaps? Is it 9? No, 9 is logarithm derivatives. So I believe it's 7 then. Vertical. Oh, 7 just implicit? Oh my goodness. All right, I need to go to my curriculum doc. Here we go, chat. Curriculum doc. Hi, pink drink. Huge. Where's my pink drink, Mrs. Schachter? Okay, I got to go to my curriculum doc because I can't find it. For Genevieve, curriculum. Okay, where is this? Derivative of inverse trigonometric function, 3.8. Is that not the very first section I opened to, chat? Literal first section. I called that. Okay, so then derivative of inverse trig functions, practice problems. I was literally open to this document. Maybe I just didn't go far enough. Here we go. Got it. Okay, Genevieve, this is your problem. I'm just going to write it down on my iPad. I don't need to take a fancy picture. So y equals arc sine 3x over 4, then dy dx equals question mark. Okay, I've got that back. I've got this. 3 minutes and 36 seconds. Nah, it's not going to go down like that. We're going to kill the stream, not the stream. We're going to kill the iPad. And then we're going to close the software. We're going to reopen the software. We're going to start it up again. We're going to do a wireless connection. We're going to share my screen. Chat, we're getting good at this. This is efficiency. Efficiency. The program is slow, not me. I will take a glorious sip of pink drink. Oh, man. Starbucks would just pay me 1 pink drink a stream. I would say Starbucks every time I'm streaming. This is still not loading. I'm trying the mirror again. It's buffering. Oh, there it goes. It went. Yes. All right. Okay, this problem is for Genevieve. This is an inverse trig derivative done without a formula memorized. This is just a right triangle trig problem. Okay, so in order to solve this problem, the first step we need is to get rid of the sign, the arc sign rather, to sign everybody, because we can't quite work with a problem that involves an arc sign. So we kind of just think to sign everybody, okay? So I'm going to go ahead and rewrite this problem as sine of y equals, now the sign of an arc sign cancels out and just gives me the answer of 3x over 4, okay? Now I need to take the derivative, and actually I'm going to rewrite this because it makes me happier, as 3 over 4x, okay? That just makes me happier, not getting confused with, do I have to quotient rule 3x over 4? No, don't get carried away here. Now it's just sine of y equals 3 over 4x. Take the derivative of both sides implicitly, okay? So the derivative of sine is cosine y, but I have to chain it, dy dx, equals the derivative of 3/4 x is simply 3 over 4. So if I divide both sides by cosine y, I get that dy dx is equal to 3 over 4 cosine y. And that's the final answer to the question. I just have to figure out what is cosine y in terms of x. In order to figure out what is cosine y in terms of x, I look to this statement right here. Okay? This statement right here states that sine, which is, according to SOHCAHTOA, opposite over hypotenuse. All right? So sine is opposite over hypotenuse, and it's 3x on top, the opposite, and 4 as the hypotenuse. I'm going to draw a right triangle. Now this right triangle, my angle is y. It can go anywhere you want except the 90-degree side. Now opposite angle y is 3x, because the 3x right here, okay? And then hypotenuse is 4, which is opposite the 90-degree angle. And then I don't know this side right here, which is my adjacent side. I need to find my adjacent side, because if I look down here at the final answer, I know that cosine y is equal to adjacent over hypotenuse. So if I can find an expression adjacent over hypotenuse, stick it right in there for cosine y, simplify, bing, bang, boom, I'm done. All right, so I need to do a little bit of Pythagorean theorem in order to figure out the adjacent of this triangle. So that means that a squared, which is, I'm going to call it adjacent. I'm just going to leave it as adjacent, whatever. Adjacent squared plus 3x quantity squared is equal to 4 squared. So the adjacent squared is equal to 16 minus 9x squared. So the adjacent side is equal to the square root of 16 minus 9x squared. And that is going to go right here in my triangle. And I don't really need to write this, to be honest, but 16 minus 9x squared. But I'm ready to go ahead and plug this into my expression for cosine y. So my final answer will read dy dx is equal to, I'm just making sure I'm not cut off here, I'm chilling. Dy dx is equal to 3 over 4 times adjacent on top, hypotenuse on the bottom. The hypotenuse is still the 4 from before. I didn't have to find that or anything. Boom, boom. This is equal to 3 over the square root of 16 minus 9x squared. And this is the answer to the derivative. No rationalization needed. Okay, chat looks empty, so I think everyone's good with that so far. That's a great problem. Formula memorizers, what you would have done is just simply said, what is the formula of the derivative of arc sine? I'm not a formula memorizer, but I think it's 1 over the square root of 1 minus x squared, something like that. You're welcome, Genevieve. No problem. Happy to help. So yeah, formula memorizers, you would have just plugged it right in there and bing, bang, boom, you got it done. Okay, solid. The chat is open, guys. We have 12 glorious minutes together. Is there any topic that you feel as though you need some support in, or just a general question? How's your studying been going, by the way? 15 viewers in the chat. That's excellent. Can we do an IVT question? Jason Buca asks. Sure, Jason. Let's go get an IVT. I'm going to open up to my curriculum doc. I'm going to go to the intermediate value theorem, which was first introduced in, wow, when was it first introduced? Unit 2, I believe, right? We did intermediate value theorem with limits. Maybe a little continuity. Let's just take a peek here. There it is, the intermediate value theorem. Now, I don't actually have any problems. Maybe we could go steal a problem from the video, Jason. Okay, we're not building my online business. Whatever ad this is, you just got plugged to 14 calculus fans. Jason, maybe we could, here we go. Maybe we could steal a question like this, Jason. Okay, I'm just going to steal this right from the video, Jason, just because I don't want to have to go digging for a question. So it says f of x, you know, I might just talk this one out because it's going to be really quick. You know, here's the question, right? Does a 0 exist on the interval 0 to 3? And what essentially I'm trying to ask you is this function ever equal to 0? So pretend this is some FRQ question, and you're trying to determine, is it ever 0? For example, the FRQ question we did today together was, are these two functions ever equivalent? So is their difference ever equal to 0? The interval provided was 0 to 3. So I simply started by plugging 0 and 3 into the interval. 0 plugged in gave you -4. 3 plugged in gave you 5. And therefore, does a 0 exist? The answer is, of course, it does, right? A 0 definitely exists because you're going to have this function goes negative to positive, and if it's continuous, then it has to cross the x-axis, which would be y equals 0. Jason, that's an IVT problem here. Let me get my face out of there. Go away, Mr. Schachter. Do you find that helpful? It's kind of what the IVT is looking at. So again, this is just like a random question I asked of x squared minus 4, but awesome. Thumbs up from Jason. But definitely make sure you're aware that it could be any formula. Okay. All right, we're putting me back in. Mr. Schachter's back. And Genevieve asks, will theorems like the MVT and IVT only be FRQs, or could they pop up in the multiple choice? That's a great question, Genevieve. Those are typically going to be FRQ onlys. The reason is because they usually come with a justification piece, right? Proving why you can use the theorem and not just using the theorem. What's an example of when you have to write out the FTC to justify work? Writing out the fundamental theorem of calculus. I don't know if you ever need to write the words fundamental theorem of calculus, Ellie. You know, part 1, it would just be the derivative of an integral. And kind of while I have you here, chat, and you can't go anywhere because you're stuck with me for now, just remember there is one claim or clause, I guess, in the fundamental theorem of calculus that states it's not necessarily just plug the upper bound in there, right? So like the fundamental theorem of calculus part 1 says the derivative, I use the right notation, the derivative of an integral is the original, okay? So I suppose this kind of matches the textbook's notation, all right? So like f prime is going to become f of x. But just remember that when you plug the upper bound in, okay, you have to multiply by the derivative of the upper bound. So it becomes times 6x. This is really important. It is often a multiple choice question, okay? Often a multiple choice question to get you to think the derivative of an integral, you forget the upper bound. So just be careful there. Is there a way to access these practice problems, Trey? I'm not sure which practice problems you're referring to. I'm simply pulling these from our curriculum guide. So on Canvas, or are you, Dre, you might not be a Barrington High School student, in which case, if you clarify that for me, I can walk you down that road. But if you're a Barrington High, you are not a Barrington High School student. Well, welcome, Dre. I don't know where you're from, but I appreciate you tuning in. I'd say the only way you can access these, Dre, because all of these links and documents are locked for Barrington High School only, but my YouTube channel is completely public. So if you go to bit.ly/mathshaq, so this link right here, Dre, I'll put it in the chat for you. This is my YouTube channel. And all my videos are completely public. So that's probably the easiest way you can access all these practice problems, because everything else, unfortunately, is tied to our domain, which would restrict you as a Barrington High School student. So yeah, but you can have this. Dre, the easiest way to navigate through this is click playlists. And I follow everything through our curriculum guide through our playlist. So for example, AP Calc starts off with limits and continuity, and then it moves to derivatives and then applications of derivatives. And if you, let's say you go to derivatives, the entire playlist is right here. So you can kind of go through and just click on what you feel you'd like to watch. And I do some practice problems in the videos. You're welcome. I self-studied using your Google Doc last year. I don't know how I got access. I'm not a student. Marcus, unfortunately, Google redid all their privacy links. They're all different now. And when they redid them all, they forced me to be domain specific or no access at all. And I chose domain specific because while I always want education to remain free of charge, being completely public, you can imagine there's certain things that I post on my, for my students that College Board asks me maybe not to. So I usually restrict it to our students only just because of that. Can we do a definition of the derivative integral problem? The one with the Greek symbol. Oh, yeah. Got you. All right, going to my curriculum doc. Curriculum doc. Now I simply have too many tabs open, starting to close them. All right, curriculum doc. Where are we with the Greek notation? Some kind of derivative. Oh no, you know what it was? It was the integration video. I think I showed it to you because it was like the evolution of integration was the name of the video. Let's see if I can find it. Evolution of integration. Let's see if this is it. Yep, here it is. So, I mean, long story short, there's an entire, oops, did I not just click that? There's an entire course that's kind of dedicated to epsilon calculus and stuff. There's really not a whole lot we need to know. Let me kind of summarize the first couple of really important things you need to know, Katie. First of all, delta x is equivalent to b minus a over n. Okay, so I don't know if that's said in this video at some point. I'm pretty sure I prove it to you in this video somewhere. Oh, it's right here. Here it is at the top of my screen. Okay, this is number one important fact, okay? Delta x is equal to b minus a over n. That's really important because in an integral problem, you're probably going to have some expression at the end that is equivalent to delta x. And so you set it equal to b minus a over n. B is the upper bound of your integral, a is the lower bound of your integral, and n is your number of partitions. As far as these problems are concerned, they go from easy to really, really challenging. Let me get you easy first. Let's see if I have a practice problems here. Here we go. Practice problemos. Sorry, the file does not exist. I'm glad I clicked that. I got to figure out why that's the case. Okay. So, Katie, this is an example of an easy problem of what you requested. When you have a problem like this, you'll see that a lot of the Greek notation has been removed, and all you have is a limit, a summation, and delta x. Whenever you have a problem that already has delta x in it, it's not really that too bad. All you have to do is take this m sub k. This notation right here becomes our variable. So this problem is as simple as just writing 3 and then variable x squared minus 2 variable x plus 5. So a problem like that is pretty simple. I've seen multiple choices like that before. However, they can get a little trickier, and I think that I'm going to try to find, okay, I understand that you do not like this link. I need to fix this link for you guys. I actually need to spend some time this week and check all my links to make sure that they're working. So let's go to 5.2 back. I command you to go. Okay, it didn't go back. Let's go to 5.2. Oh, and by the way, I know for Dre, who is not part of my AP Calculus class, I just wanted to share this with you. Go here. Go down here. These are my Shack picks. This is a good prediction of what I feel is on the AP exam. I'm going to just pop this in the chat for Dre. Oh, it's too big by negative 191 characters. We're going to pop it in 3 at a time. So this is really helpful if you kind of want like a basis. They're very broad, but at the same time, they are specific in regards to certain categories. Oh, wow, it's still too large. I have to do the last two here. And then the last one. So Dre and anyone else who's not going to Barrington High School, this is a good guide as to what you can expect in this year's FRQs, okay? Okay. Katie, I'm going back to a hard one now. I'm just checking the chat. Can we do that? Yep. Aiden says, hi, Dre, no problem. We're going to go find a hard problem in section 5.2. Section 5.2 BHS. We're going to go to, where are you from, by the way, Dre? What high school you go to? Let's actually go to Starred Calc. Let's go to 5.2. So we're going to go here to 5.2. Practice problems annotated. Maybe I can find a good one here. There's a good one right here. Katie, here's an example of a not so easy one. Georgia, very cool. Villa Rica High School. Also came to yourself and studied. Come across your self-study doc. Oh, nice. Awesome. Happy to hear. Katie, this is an example of a problem that's not as easy, and this uses that fact that I just mentioned a minute ago, that delta x equals b minus a over n. So delta x is always the last term in your summation problem. So 3 over n is equal to delta x. And what that assumes is if b minus a is 3, because 3 is in the numerator, if b minus a is 3, and we're going to start this integral at 0, and that's an assumption that we made based on any starting point you want, and 3 higher than that. I chose 0 and went to 3. Could have done 1, went to 4. And then I took my expression, which in the last problem I showed you, you just take your expression, 3 over n sub k, or multiplied by k, and that 3 over n k is just going to become your variable x. So if that becomes x, and you're integrating 2 plus x squared, 2 plus x, this is x squared, and you're going to integrate from 0 to 3 because we chose 0 and b minus a is 3, and then we get an answer 39. So I hope that's helpful. That is another thing that we saw. Georgia's crazy. Dang, we're in Rhode Island. Yeah, Dre, we are in Barrington, Rhode Island doing some calculus. All right, chat. It is officially 2 o'clock. I definitely wanted to make sure I said this. If you have any other questions this weekend or during class, please let me know. You may email me at any time or just ask me in class, okay? Good luck studying this weekend. There's a lot to prep with. If you're stuck and you need a starting point, what I would do is I would just simply open up a Google tab, and I would type AP Calc AB 2016 FRQ, and I would just go open to the free response questions, and I would just start solving. Oh my gosh, guys, an in and out problem. An in and out problem is the first FRQ I open up. Come on. You know College Board's going to put an in and out problem on your exam this year. Nicholas, you are welcome. Chat, you are welcome. I'm excited for some more review next week. We're going to do the 2023 FRQs next week, so please lay off looking at those this week. Alex, thanks. Have a good one. Everyone else, guys, enjoy your day. I really hope you have a nice rest of your weekend, and take care. Goodbye, chat. Gotta go close out the page. I'm buried in tabs right now. There we go. Take care, everyone. Closing this stream.